Over the last 10 years, fluctuations in commodity prices and unpredictable rainfall patterns have increased the importance of managing the agronomic and economic factors influencing row crop production in South Carolina. Through supplemental irrigation, stabilization of yield from year to year can be achieved, reducing risk and assisting with enterprise budgeting and economic decision making for farmers. Due to the recent changes in water regulation and water monitoring for agricultural use in South Carolina, accurately and efficiently applying irrigation to crops is increasingly important. Providing and demonstrating economic benefit to farmers through irrigation recommendations is needed to promote sustainable row crop production in the future. Several row crop farmers across the state have invested in irrigation infrastructure, with more than 20% of the acreage on irrigated farms having irrigation. Likewise, at several Clemson University research and education centers, supplemental irrigation is utilized, and research directly relating to irrigation is being conducted. Precision irrigation technologies have evolved over time with the mindset that we can and need to do a better job with getting water to the rooting zone of the plants, improving our overall application efficiency. Technologies such as variable rate irrigation, incorporation of soil moisture sensors to schedule irrigation, variable frequency drives, low pressure systems, and improved sprinkler nozzles are all examples of how the agricultural irrigation industry has adapted equipment to improve system efficiency and reduce water use. Similar to variable rate fertilizer or seeding applications, variable rate irrigation allows farmers to place water in specific areas of the field or varying rates across the field simultaneously. With the use of GPS and solenoid valves on each drop, on-off control of the water can be realized, in addition to pulsing water on and off to vary at the application rate. While continued research is needed on implementing site-specific irrigation to row crop systems, water-saving benefits could be realized in fields that have a significant area that is non-crop, highly variable soil textures with varying soil water holding capacities, or multiple crops under one system. A research project funded by the South Carolina Soybean Board was initiated in 2020 with three main objectives. First, to determine the optimum soil moisture sensor threshold value using soil tension soil moisture sensors. Second, to evaluate season-long irrigation schedules. Finally, to determine the return on investment and payback period for soil moisture sensor technologies utilized in soybean production in South Carolina. Through this research, irrigation has been applied with an overhead irrigation system such as a center pivot. Irrigation has been scheduled with soil tension type soil moisture sensors such as a watermark sensor installed at depths of 6, 12, and 24 inches to monitor soil moisture within the top 24 inches of the rooting zone. All of the soil moisture sensors that were used in this project were installed directly after planting within the planted row. Treatments have consisted of three threshold values where plant available water was allowed to deplete 25, 50, and 75%, and a non-irrigated treatment was included for comparison purposes. From this research, we expect to be able to determine the optimum soil moisture sensor threshold for soybean grown in South Carolina, which maximizes profit and water use efficiency. This research fits into the Clemson University Research and Education Center mission by connecting fundamental agronomic practices of irrigating soybeans with precision agriculture technologies to make the most of our irrigation inputs while making irrigated soybeans profitable. This research is important to South Carolina soybean growers because it will ultimately assist them in accurately scheduling irrigation in soybean to remain competitive and productive.